We're going to do all of the odd numbers on your 6.5 to 6.6 quiz review. And hopefully you can use that to help you study and do the even ones as you prepare for your quiz. So the first one here says divide. Says use long division for 3 and 4, but we're on number 1, so we're just going to divide. When we have a polynomial, so 2 or more terms, divided by a monomial, what we can do is we can write each of those terms divided by the 4r squared, but we can write it as a fraction. And what we know here is this 4r squared is a common denominator of all 3 of these terms, so we can put 4r squared under each one. Now that we've done that, we can go ahead and simplify each term. So 16 and 4, they both reduce by 4. So 4 goes into 4 once, 4 goes into 16 4 times. R cubed divided by r squared. Remember, when we divide with exponents, we can subtract. So this will give us 4, and then r to the 3 minus 2. So r to the first power. So again, we do 3 minus 2. And then we got the next one. 4 reduces with both of these. 4 goes into 4 once, into 12 3 times. R squared divided by r squared is just 1. And so this term, we're just left with 3. And then our last one, 4 reduces. We can think r to the first minus 2. So we have 1, and then we have our plus sign. We have r to the negative 1, but we remember we don't want to leave negative exponents, so we have 4r plus 3 plus, and when we have a negative exponent, we do 1 over that thing, so r, and we change the sign to positive, so r to the first, but we really don't need this 1 here. So there's our answer for number 1. Again, write it divided by this monomial, and then this monomial is a common denominator to each term. So we wrote this red part here, and then we simplified. Number 3, here we want to use long division. So for long division, we put what we're dividing by out here. So we have n minus 9, and we're dividing into n cubed minus 3n squared minus 58n plus 32. Notice this goes 3, 2, 1, and then a constant, so we don't need to leave any blanks here for missing ones. So remember, what we do is we divide, multiply, subtract, and bring down. And so when we divide, we think just this term here, just the n, like n cubed divided by n. So n cubed divided by n is n squared. So we have n squared, and then we multiply. We multiply by both these things, so n squared times n is n cubed. N squared times negative 9 is negative 9n squared. So we just multiplied, and now we subtract. So we're going to subtract, which means we'll change these signs here. So this positive n cubed will change to negative. This negative will change to positive. And we can go ahead and subtract. N cubed minus n cubed is 0. That's supposed to happen. Negative 3n squared plus 9n squared is 6n squared. So we just did our subtracting, and now we bring down. So we have minus 58n, and we just brought down, so we're now back to dividing. We can do 6n squared divided by n. Another way we talked about is we can think what times n gives me 6n squared. Whichever way we think about it, we will get plus 6n. Then we multiply 6n times our binomial, so we get 6n squared minus 54n. So we just did our multiplying, and now we subtract, so we can change our signs here. And now we combine those. This becomes 0 as it should. Negative 58n plus 54n is negative 4n. So we did our subtraction, and now we bring down again. So this is plus 32. And we do another division. Negative 4n divided by n is negative 4. And then multiply this out. We get negative 4n. Negative 4 times negative 9 is positive 36. And then again, we can subtract. So we change these signs. This becomes 0. And 32 minus 36 is negative 4. That is our remainder. So we can put remainder negative 4, or we can put plus negative 4 over what we're dividing by n minus 9. And here is our answer for that division problem. So we have 1 and 3 completed. Let's move on to number 5. This says divide using synthetic division. Put your answer in polynomial form. So for synthetic division, remember what we do is we take the opposite of this. So we're going to use a positive 8. And we put our positive 8 over here. And then we list our coefficients. If a term is missing, like if we didn't have an a squared term, we would make sure we put a 0, but all of them are here. We have a 1, a cubed, a negative 9, a squared, a negative 1a, and positive 70. And then we follow our process for synthetic division. We bring down the first term, so bring down the 1, and now we just do a bunch of multiplying and adding. So 8 times 1 is 8. Add those, you get negative 1. 8 times negative 1 is negative 8. Negative 1 plus negative 8 is negative 9. And 8 times negative 9 is negative 72. And we add those, and we get negative 2. So we did the process, but now what we have to do is write it as a polynomial. We divided an a cubed by an a, so when we rewrite these coefficients, we drop down one level. We were at a cubed, so this is going to be a 1a squared minus a 1a minus 9, and then we put plus negative 2 over what we were dividing by. Don't put the 8. Make sure you go back to this form up here and put the a minus 8. So there's synthetic division. It's nice and simple. Make sure you know how to set it up and follow that process, and then rewrite it back as a polynomial. Use the remainder theorem to find the remainder of each quotient. So it's saying here's a function, negative 5n cubed minus 13n squared plus 8n plus 18. If it's divided by n plus 3. Now we want to use the remainder theorem. So the remainder theorem states if we plug in negative 3 to our function, that will give us the remainder. So when you come across this problem, even though it talks about division, we're using the remainder theorem. So to do that, we're going to plug in the opposite here. So we're going to plug negative 3 into our function. So we'll have f of negative 3. And then we'll simplify this. So we have negative 5. Negative 3 cubed is negative 27. Minus 13. Negative 3 squared is positive 9. Plus negative 24 plus 18. Now we go on to multiply these. Negative 5 times 27 is going to be 135. It's going to be a positive 135. Negative 13 times 9 is going to be a negative 117. We can combine these two while we're at it. So negative 24 and 18 is negative 6. And then we actually combine those two. So we got 135 minus 123. And 135 minus 123 is 12. So the remainder would be 12. We didn't do the division. We just plugged in the opposite of this into the function. That's using the remainder theorem. Next one, number 9, factor each completely. Well, when factoring, the first thing that we want to do is see if there's a common factor. So we have a 3a to the 4th plus 18a squared minus 120. 3 does go into each of those, so we're going to factor out a 3. We have a to the 4th plus 6a squared minus 40. So we just factored a 3 out of each term, and now we want to keep going. Remember, we call this a to the 4th plus 6a squared minus 40 quadratic-like. It's not a quadratic, but it's in that form. So what we're going to do is we're going to put our two groups of parentheses, and we're going to think, what can we multiply together to get a to the 4th? And we have an a squared times an a squared. We look at our second sign here, and this is negative. So in order to get a negative 40, we need one positive and one negative. And then we think of our factors of 40. That will, one being positive, one being negative, that will give us this 6 here. So we have 1 and 40, 2 and 20, 4 and 10, 5 and 8. And it looks like if we subtract these, we can get 6. So we want 10 and 4, which we can quickly check. 10a squared for those inner ones, and the outer is negative 4a squared, which adding together would be 6a squared. We can keep going though, because it does say factor completely. Notice we have a difference of squares here, an a squared minus 4, which is a perfect square. So we have a squared plus 10, and then this factors to a plus 2 times a minus 2. Remember, that only works if it's positive. If it's a negative. So we don't do this here. Also, we usually only do it when it's a perfect square, not with things that aren't perfect squares, but definitely only if there is a negative. Here's another one that says fact each completely by grouping. We still could look at each term and see if there's anything in common to factor it out of all 4 of them. There is not. We start looking, looks like 5 goes into these 3, but it doesn't go into here. I'm going to mention this, it's not here, but I'm going to mention if this third term is negative, which I know it's not, you would put plus a negative, because that will help with keeping our expressions the same value. But here we go. For grouping, we group the first 2 together. We group the second 2 together. And then we look in these first 2 and think, is there anything in common in these 2? And notice 5p squared is in common. And we're going to look, well, what's left over after we factor out a 5p squared? And we would be left with 5p plus 4. And then we're going to look at this second group, and we're going to think what's in common in here. 3 goes into both 15 and 12, so we can factor out a 3. And what's left over now after factoring out a 3 is 5p plus 4. I wanted to color code it here so you could see we have this 5p plus 4 in common, and when we have something in common, we usually just factor it out. So we have factor out that 5p plus 4, and we think, well, what's left over after we factor this 5p plus 4 out of each term? And we have a 5p squared plus 3. When doing factoring by grouping, sometimes these factors can simplify more. In this case, they can't, so we are done with this one. And number 13, state the possible rational roots for each function. Then factor each and find all rational zeros. So find the possible rational roots. When we see that, that means apply the rational root theorem, which is our C over D. So we'll start with that. Our values for C are factors of 5, which we put plus or minus 1, and plus or minus 5. D comes from the factors of the leading coefficient, which in this case is 1, which is just plus or minus 1. And then C over D is every combination we can make over here. Well, there's not that many combinations in this case, but we have 1 over 1, which is 1, plus or minus 1, and 5 over 1. If there were more terms here, like a 2 or a 3, we would do 1 over 2 and 1 over 3. But we only have 4 possibilities here as our factors. So we answered the first part, possible rational roots. Now we want to factor. Remember, what we've been doing to factor is we take these possibilities and we use synthetic division to see if it's a factor. So we're going to start with 1, and we're going to go from there. So we'll start with our positive 1. We list our coefficients: 1, negative 16, 56, and negative 5. And we bring down, multiply, and add. So we bring down the 1, multiply. 1 times 1 is 1. Add these together, I get negative 15. 1 times negative 15 is negative 15. Add those together, and we get 41. 1 times 41 is 41. 41 and negative 5 is 36. So 1 did not work. Remember, what we're doing is looking for a 0 here. So let's try negative 1. So 1, negative 16, 56, and negative 5 again. Try to squeeze this in here. We're going to bring down our 1, multiply, gives us a negative 1 here. Adding those together is negative 16. Negative 1 times negative 16 is positive 16. Adding those together gives us 72. Negative 72, and that's negative 79. So that doesn't work. So let's come and try 5. So we have 1, negative 16, 56, and negative 5. Once again, we bring down our 1. We multiply, we get 5. Adding these two together is negative 11. 5 times negative 11 is negative 55. Add those together, we get 1. 5 times 1 is 5, and we get a 0. All right, so we have 5 works, which means x minus 5 is a factor. So we put x minus 5. We put what's left here as the coefficients of our other polynomial. So we were at x cubed. We're dropping down a level to x squared. So we have x squared minus 11x plus 1. Now at this point, we would try to factor. So in this case, in this example, this doesn't factor anymore. Again, if it did, we would go ahead and we could factor more. We would still have our x minus 5, and we would keep factoring. But as we would try different possibilities here, which would just be 1s, it's not going to go any further. So in this case, we're done with the factoring. To solve, to find our rational zeros, in this case, we just have one rational 0, and it's x equals 5. Because we figure out what makes this 0. Again, if there were more factors here, we could find other rational zeros. But our answers, here's the possible rational roots. Here's factoring. We factored it. And then here is the only rational 0 in this case. So there's all the concepts you need to study to be prepared for your quiz. Make sure you go over the rest of the quiz review and prepare.